So, hello and welcome back to my exploit development series. This is the first video in a while in the series, and last time we took a look at exploit education, and now I decided to get back to it, and I want to work through Emporium, which is a small wargame based on return-oriented programming. So in this video we will just start with the first challenge here. I already prepared a small directory here where we have folders for all our challenges, but that is all preparation that I've done. Let's take a look if we can solve it. Let's start with the first challenge, Ret2Win, and here we just need to locate a method that we want to call within the binary, call it by overwriting a saved return address on the stack, and then we will only do the x64 version of the binary. And yeah, here's some description, but let's see if we can solve it. So copy this link, download it, and then we have the challenge here. Then we can remove the zip file. And then we have a flag and our Ret2Win binary. So first of all, let's run checksec on our binary, and we can see we have a non-executable stack, no stack canaries, no positioned and independent code. It is not stripped, and it has partial rel row. So far so good. Let's take a look in radar, analyze the file, and let's first of all give us a function list. So let's see, we have a pawnme function, a Ret2Win function, and there's also the main function. So let's take a look at main first. Here we can see a call to pawnme in the main function. Yes, as we can see, pawnme gets called. So let's follow that call. Here it is. Then we are in pawnme. Then here's an output of thank you. And there's no call to Ret2Win. There's a call to read, then there's some output of a string, and then the NOP instruction, and then we leave. But afterwards, here's the Ret2Win function that we don't call, but probably this is the function that outputs our flag, and that is correct. As we can see here, Ret2Win outputs our flag, so let's note that down. And I think that's already everything we want to see here. So let's quit out of here and open this in Jeff, and then simultaneously open a new window where we will write our exploit. And we can already start here with our boilerplate. And the process is, of course, to win. Then what we want to have the offset of how many bytes can be stored on the stack until we overwrite our return address. So this will be this one here. Let's for now just say 20. Then we want to have the address of our Ret2Win function. So this will be stored in here. Then we might need some padding or stack alignment for system to be called. If we take a look here, we can see here that system is called, and system needs to be stack aligned to 16 bytes. So we might need some padding here, and that padding will be achieved by inserting some NOP instructions. So we place some returns and just pop them off the stack basically until we then return into the Ret2Win. And we already have a return instruction here, so let's just use that here. Then we can also print us the address of Ret2Win and fill it in here. And this is only possible because we don't have positioned independent code, and there's no ASLR basically happening. So the binary always gets loaded in the same address space, so we don't need to worry about anything here. We can just use these addresses. Otherwise we would have to find out where the ELF module got loaded in RAM, but we don't have that here, so that's good. Let's just have a padding of 1 right here. And then how our payload would look like is the classical base times our offset. Then we would have the returns times heading, and then we would have the Ret2Win, and then to sane place again. So let's have the main here. So, and then we can return to main like this, and then we can already send it. As we can see in Emporium, there we called read, so we need to send a line. And now we only need to find out which offset we need to use. So let's find that out. We can do pattern create. Let's do 100 and then run. And as we can see, for my first trick, I will attempt to fit 65 bytes of user input into 32 bytes of stack buffer. What could possibly go wrong? And then, of course, we can apply our cyclic pattern here. And you can see we got a 6F, a segmentation fault, and that means we overflowed the stack and it crashed on this instruction, which is a return. So it wasn't able to pop the return pointer from the stack. And now we need to find out what RSP points to. So RSP is pointing to this, which isn't a valid memory address, so it can't return there, and well, hell breaks loose. So take a look at which offset that is, and it looks like we found that pattern at 40. So let's use that as our offset. Then what do we have here? 40 plus 8. Take a look here. So 40 modulo 16 is 8. So we should already have it 16 byte aligned now when we put another return here, but I'm a little bit unsure. So there's nothing we can do other than to try it out to make sure we got everything correct. And maybe something we need to take into account. Let's run this again so we can see. This is our operation, then and so something like this. And that looks right. So as we can see, thank you, well done, here's your flag, and we already got the flag. And we are done, and yeah, as you can see, everything worked correctly, and yeah, thank you for watching again, and we will continue with that in the next video. Thank you.